piggyback off of how I ended yesterday's notes. You guys, I did do this one correctly, which I'll start with it. I told you in the other hour I did this one a lot more complicated, and feel free to put this wherever you want. I'm just coming up with two examples from yesterday. And remember, yesterday I did do that right. I'm getting a little buzzing in my ear. That might be a problem. Or if these headphones are going bad. Remember I did that, the intersect. That's what we did yesterday. Problem with this question is cotan is not on your calculator. And that kind of leaks into today. Cotan is 1 over tan. So we did this. We did this with the graphing calculator. Left side, y equals 2. That's what it says for p of x equals 2. So I put 2 here, and then I put y1 equals 2, y2 equals this. I don't have a cotan button. All right. And then, okay, now I don't want to keep like messing with your mind and going back and forth. We did have a discussion today with the group. The group said that we do want to test graphing again. So here we are. This is where the test is, April 12th, and they are going to throw graphing concepts. But the idea is we're continuing with solving, even though today may seem like a switch of gears. Graphing can be used for that, so we should still be talking about graphing. Okay, I guess. All right. You won't actually physically have to graph, but you'll have to know things about graphing. So, right around here, we're here right now. So I think right around this day, we're going to review some graphing attributes of all the functions, even though I'm going to talk about it today. So here's what I mean. Here's another question that we had from yesterday. Remember this one? And you were up on the board for this, and and feel free to stick this anywhere you want. Don't care. You don't have this on your note sheet right now. Subtract 2 and then divide by 5. Then I said, okay, that's not a unit circle value, so you had to inverse sign. Remember you inverse sign, and you got x equals like this negative 0.41. I think it rounded to that. How many people recall that answer? Okay, well, we could do this maybe a little better way, because then what's hard about this is the answer was supposed to be between 0 and 2 pi, which that number is not between 0 and 6.28. That's what 2 pi is. So you had to know that this is the quadrant 4 answer, and then there's also a quadrant 3 answer, because that's also where sign is negative. You guys got those answers. I don't want to go over that again. We could actually do this the same way we did the one over there. All right. And that's what's good about this. But you have to have an expectation, have to have some knowledge, and not be just a button pusher of what I expect to see. So the sine function right in the middle of this, yeah, what? Oh no, you didn't tell me. Oh gosh, so I have to start all over. Let me see. I wonder if it's actually son of a. That's me. So hopefully this is working. Otherwise, this has no sound. All right, not plugged in. It should be this crummy, really bad, microphone on the computer. Okay, so sine is 2 bowls, right? 2 bowls. All right, and then remember the low point, which happens at this 3/4 value. By the way, this is 2 pi. This is pi, and this is 3 pi over 2, and all those other things. All these values that we should know. And this one's pi over 2. I'm not going to write it. That's the high point of 1. The expectation of picture, because then, where negative 2/5 is? Somewhere right around here. Input say it. So I'm looking for these input values that create those output values, negative 2/5, or that output value. And then another powers that be, another teacher said, you know what? And these kids should be responsible for inequalities, solving inequalities. Because if I just turned this into a less than instead of a equals to, then it would be all of these x's in between, because these outputs we've been doing this since August, solving inequalities, checking net watches. I love it. Watch. Teaching in America. So many things to distract the kids. Oh, it's so much fun. Anyway, all right, so let's go to the graphing calculator. Graphing calculator. All right, check that phone. I'm jealous. Negative 2 divided by 5. Watch, phone. Watch, drink. Ooh, it's snowing outside. All right, sine of x. Who's doing their homework right now? Because they didn't do it but last night, but they're not listening to the note. That happened second hour. Teaching in America. Fumble. All right, here we go. Now this is what we got to do. Input, say it. And what were the directions for this again? Solve from 0 to 2 pi. So I said input output is our input should at least be from 0. Why don't I go to -1 though? I like to go a little bit past my parameters. I like to go a little bit farther. And 2.2 pi is 6.28. So I'm going to put 6.3. I hope I didn't blow a brain gasket there. This one a little bit bigger than what 2 pi is numerically, because that's what the x's mean. They're those are the inputs that I do in the graph. And then for the y's, this is sufficient. I should know sine goes from 1 to -1, high to low. 4 to -4 covers it. I don't want to make it 1 to -1 and be right on the edge. Boom. So there we go. And then I could see these, and what am I gonna actually access? I'm gonna access what in this menu that we have like a million times. A million's an exaggeration, but it is at least like 20 to 30 times in this class that we solved equations like this. We did it in August or September with quadratics, V graphs. Most recently, we probably did it with ln or natural log and exponential graphs. We definitely did that. And that was one of our answers. What that answer is 3.14 plus 0.412, because I told you 0.412 was a reference angle. And then second, calculate 5, intersect. Let's move over. And you don't have to go far. You just have to get closer to it. You don't even have to get right on it. And then just press enter 3 times until you get the word intersection. And then that answer was 2 pi minus 0.412. They had a full rotation, but then backwards 0.412. And that's how we did it yesterday. But I think that's better. That's faster. And it has less like, oh, I have 2 answers. I'm in quadrant 3 and quadrant 4. So I did want to reference that. And now we can move into our notes. All right. You have a nice little positive shirt. Every problem has a solution. All right, anyway. All right, so here we go. Angie, Dean's office, immediately. All right, sorry. Oh, you're on the video too. We didn't say your last name. No, don't sue me. Don't sue me. The sound might not even be on anyway. Ooh. All right, here we go. Don't break my door. Stop making that noise, whoever's going. Teaching in America. Okay, so these are identities. This is what an identity is. Hey, can everyone say this word? Substitution. That's all you're doing today. It's substitution. And then tomorrow we're going to put the 2 together. Right? So I know this is going to come out of left field here, but this will aid us in solving some equations again tomorrow using some of these identities. Wax on, say it. That's from the Karate Kid, the good one, the one from the 80s. And that just means, why are we doing this? To practice and memorize. That's what it is. We should already know this. Cosecant is the flip of sine. So this is true. This should not be like, oh my gosh. Right? And then same thing with secant, and cotan is the flip of tan. You know what else that means then? Then sine must be the flip of cosecant. Now you'll never probably use this one, but maybe. I just want you to know it's true. Sine is the flip of cosecant. So sine equals 1 over cosecant. 1 over sine equals cosecant. It's just inverted. It's the same relationship, just flip. And then you guys should not be having a brain gasket blown on this one, because I told you, when you look at your unit circle, by the way, what is this? Is that cosine or sine? Cosine. And what is this? And then what did I have you do to find tan? I had you take sine over cosine. 1 over root 3. Why did I ignore the 2's? What happens to the 2's on the bottom? They cancel. 1 over root 3 is root 3 over 3 for tan. And then for tan of pi over 4, root 2 over root 2 is 1. That's why tan of pi over 4 is 1. And then tan of pi over 3 is root 3 over 1. What am I saying? Every single time we evaluated tan, we did sine over cosine in order to get its evaluation. And then what's cotan? The flip. So this ain't no thing, chicken wing. All right. Now, that unit circle over there. This is called what? Starts with a P. P what? Parabola. What is this called? Pythagorean P. What's this called? A pylon. Just pick P. A python. Poopy. Just pick P words. All right. Next. Hey, in a unit circle, what's R equal to? What's R equal to? What's R equal to in a unit circle? Unit circle. What's a unit? 1. So that's how this happened. See that? And then what did I say? What did I say the x coordinate is the same as? What's the x coordinate in the unit circle? Cosine. What's the y coordinate? Oh, they flipped them. They switched them. It doesn't matter. That's a commutative property. I'm still going to do this. And I don't know why I'm still talking. I really hope that. I think the sound's going. It's just going to sound terrible. It's computers. Hey, whatever you do to one side, say it. Do this. Just humor me. This really should be something. I'm going to decide. And by the way, division is distributive as well. I'm going to decide not a unit circle. Any R value that I have, I can do this structure that I'm going to do right here. What is R squared over R squared, by the way? And I'm going to put my work over this way. What's R squared over R squared, everyone? Ooh, you hear that? See that light flicker? All right, and then I want to write this. I'm going to be really, since this is on the internet and thousands and millions of people watch my videos. I couldn't even get that out with a straight face. All right, I just want to make sure I'm mathematically, syntactically correct, so we don't get those, people on social media. Look at this idiot; he didn't do the math syntax right, and then I get canceled by culture, and then I end up living in a ditch, eating grubs and living off rainwater. I can't have that happen. All right, but anyway, so I did that way. And I wrote this like this, and then sir kicks or ticks. Hey everybody, what's sir? What's sir mean? Sir means sine is y over r. So if I drew this triangle in a coordinate plane, I could say the y over r fraction, that's also equivalent to the sine of the angle measure in question in standard form. I said that mathematically correct. Don't cancel me. And then what's x over r? Cosine of theta. And then we already established that that was 1. And then I'm just being really crazy with the math syntax, but we did actually do this before. We did actually ask you questions like pointing down here. What's sine squared of pi over 4? What you had to do is do sine of pi over 4, get root 2 over 2, then square the answer. All right, it's just a math syntax thing to write this like this. It's mathematical laziness. Not really. It's the point of symbols and using shortening like log base e is ln. I don't like writing 4 things. I like writing 2 things. I don't know if you remember that log base e is ln, but just thought I'd throw something out from the past. All right. Okay, so now we get to this section. And you really didn't have to write all of that. I was just deriving. And then I'll show you why. You have to have these memorized. And actually, you might have a quiz on this tomorrow, just memorization quiz. Woo, you can't do that. I have rights. Yes, I can. All right, and I will. All right, because it's stuff that has to be memorized. Memorization's been a huge disappointment this year. The unit circle itself. So we got to work on it. I don't know what else to do. So we're going to keep going on this. All right, so I have this one. There are others. And actually, I'm going to do this 2 ways. Not that I have the time to do it. I couldn't. Anyone? Care less, because it's important to show you ways to survive and you to listen and not sit there and do your homework from yesterday because you didn't do it last night and not listen to the notes like someone I had in my second hour do. Actually, 2 people. Yes, you saw it. He was a witness. Witness me. Parading. Hold on. I don't do that. Ho, ho, ho. You didn't hear that. Let me cover the parading. When have I ever? All right. Anyway. Yes.
Walks up there holding the homework.
Yes.
And
All right.
he-
Yes, I did. Lecturing, not berating. All right. So division is distributive. Division is distributive. So it says, hey, divide by cosine squared. By the way, everyone, what's cosine squared over cosine squared? Let's focus where we're looking at. 1. Let's do the math syntax. You know why, though? I'm doing this because a lot of students don't know this. Sine squared over cosine squared is sine over cosine squared mathematically. And a lot of people mess that up. So this is the only time I'm going to write this. Some people may think I'm overdoing it, but when we get into some more complicated things, this should be something that should be taught. Let's just say that. Hey everyone, what did we just learn? Sine over cosine is. It's literally on your first page. Tan. And then you know what? This is tan of theta squared, which okay, we get it. I don't have to rewrite that as tan of theta squared and then tan squared of theta. Okay, I'm just trying to hammer down that point. And then what's 1 over cosine, everyone? Secant. Again, if you still don't know, secant is the flip of cosine. This is why this is hard for you. And it's you. It's nobody else. And if it's 5 of you, don't go on social media and say, Mr. Samuels can't teach. It's right here. We've talked about this forever about how sine. What's cosecant called? We'll say it. What's cosecant? Oh, why? Because sine is so, cosecant's a what? So from that day, you've known who and what cosecant's all about. Anyway, sine squared of theta plus cosine squared of theta. So if you're sitting there saying, how is sine 1 over cosecant? You blow my mind right now. You absolutely blow my mind. And then we're not doing all that squared stuff. What's sine over sine? I don't even care about saying this. What's sine over sine? 1. Okay, what's cosine over sine? If sine over cosine's tangent, what's cosine over sine? Cotangent. Do we have a pass? And then what's 1 over sine? You gotta go dumpster dive. Go get that pass. And then what's 1 over sine squared? Cosecant. We just talked about that. The flip of, right? Yeah. I know. Well, did they not stamp it? That's the dean's office. The dean's office don't even follow the rules. Why should I? All right. Anyway. Okay. Now here's a quick way of doing this. Sir Kixer, say it. So I don't remember these. You can always go back to this. Watch. I'm going to put this up here. This is a final, like, how can I get all these really fast? Okay, well, here's one thing you could do. Whatever you do to one side, do to the other. Let's divide by r squared. And then follow my fingers. What's x over r? Of course, you have to know that. You have to know something. So what's x over r? Cosine. What's y over r? Sine. What's r over r? Bam. Okay, I'm done with that. Well, let's decide to divide by x squared now. You got to know something. What's x over x? I'm an organist squares. 1. What's y over x? Tangent. What's r over x? Secant squared. So that's the second one. Okay? And then what happens when I divide by y squared? Well, I get y squared over y squared, which is what? At least I know r over y is what? And then x over y over x is tan. So what's x over y? Cotangent plus 1 squared, equals cosecant squared. This is the quick and easy how I can get all 3 of these identities just like that. But it requires something. It requires knowing Sir Kicks or Ticks. All right, then I do have to cover this. Hey, what do you think cosine squared is equal to? No, I'm blocking you, so I just want you to know I'm live in class. What is cosine squared equal to? All I'm asking is do a little whatever I do to one side, say it. Do to the other. So what's cosine squared equal to? Well, no, 1, in reference to this, 1 minus sine squared. And I can't, oh, wait, another thing to memorize? No. You got to be able to just do a simple little, okay, I see 1 minus sine squared. Okay, that's like reshuffling this formula. All right. Oh, okay, that's equal to cosine squared. Substitution. This is what's going to happen. All right, I better get more answers on this one. Then what's sine squared equal to? What's sine squared equal to? 1 cosine squared. Someone really likes answering questions in here. And then I should have been color coding this. All right, and then what does that mean? Cosine squared of theta minus 1 equals. What does that mean? Whoa, mind blown. What's cosine squared minus 1 equal to? Who said it? Net. Did someone say net? Negative. So if I multiply this by a negative, I multiply that by a negative. And I could do this forever. Not forever. There's only certain forms that could happen. Hey, you want to get nuts? What does 1 equal pertaining to this? How would I get 1 by itself? What would I simply have to do? Subtract. So wildly, secant squared theta minus tangent squared theta would equal 1. That sometimes comes about. That's a beautiful substitution. All right, but then like tan squared by itself, I'm just messing around with this, just subtracting things from both sides. Secant squared minus 1. It's the same formula, just moving things around through subtraction, and that's it. If I put negative 1 equals negative positive. That would just switch these signs. One more just for fun. 1 equals cosecant squared minus cotan, because I could do this forever. I could do it forever. Not forever. I could write 4 alternative forms just by moving things around through subtraction or dividing by negatives. It really is the case. Okay. Yeah. All right. So here's what we like about this. Again, wax on, say it. This is only the purpose is to use your identities and not have to stare at them. All right. But really, what we really should focus on is here. These tips, they are good tips. Really, what you should do is write everything in terms of sine and cosine. That makes them the same variable, and then the variables can cancel. If you do have squareds, it still may be up here, but squareds might imply a Pythagorean Pythagorean sub. Say it, substa. When something is equal to something else, you can substitute. That's really what's going to happen here. That's really what's going to happen here. And then try to get it in terms of one trig function. We are missing one thing. We do have something about common denominators and adding fractions that I do have to cover. Okay, so let's just get to the brass tacks of it. First things first. All right, now I just asked somebody, what's cosine squared on this one? And they said 1 over secant squared. You're not wrong, but that has nothing to do with this question. All right, so when I ask what's tangent, anyone that says 1 over cotan, does that help me on this? Is this a cotan over here? Yes or no? That does nothing for me. That's why the thing that you should do is turn these into sine and cosine, or in terms of sine and cosine. And that is the truth. So since tan equals that, I can replace it. So substitution. And then what I better understand, and here comes mean Mr. Samuels again. He is a curmudgeon because of what happens to him daily here. The destructive behavior of students towards their grades, and then not taking ownership of it. Oh, it just drives me nuts. But anyway, fractions. You got to understand cosine's on the top, so make it on the top. Like I said yesterday, tan of x equals 0. 0 over, 0 over, 0 over. And I keep saying it until someone puts 1 and then is able to do y over x and understand. All right? And then who cancels? Cosines. All right, so I'm not going to over-explain this anymore. And that is simplified because it's smaller. It's less things. All right? And it is equal because I did equal substitutions. Oh. Is this true? Yes or no? I was afraid because if you do that, you should be arrested mathematically and carried out of this room. I'm glad that happened right there. This is called a 6/5 equals 2 error. How many people remember that thing that I said in the past? Anyone? I don't remember anything you say, Mr. Samuels, because I turn you off. All right. I have done this all year long. It's been a while though. Isn't 6 5 plus 1? Mo knows. He just doesn't want to. Mo, you heard this a lot last year. Isn't 6 5 plus 1? Yes, Mr. Samuels. Let me get my calculator. All right. And then what happens to the fives? Do they cancel? And then this is, so 6/5. Is this true or false? This is false. You want to know why? This is mathematically the worst thing you could ever do, but it happens all the time. And it happens on questions like this with way too many students that they take these cosine squareds and they cancel them. You can never, ever, 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 ever take a part of a sum or difference and just take a part of it and cancel it with something else. That is a 6/5 equals 2 error. I have this written up there though. Does anyone know what 1 minus sine squared or 1 minus cosine squared is equal to? Sine squared. And people that are going to blow a brain gasket right now are half paying attention. They're half paying attention to the whole thing. It literally is written right there. Literally is written right there. And that's what I mean about substitution. And this does simplify things. This does make it less. All right. Oh, and then by the way, what's sine over cosine? Tangent. It's over. Those that actually do and actually get into this stuff actually enjoy these because they're like puzzles. They're like doing math puzzles. Oh my gosh. And then those that enjoy these really enjoy this next one because what's cosine squared plus sine squared? What does that equal to? Gonna cry. 1. And you're allowed to turn that into 1 because that's what 1 is equal to. Right there. So I'm able to substitute. That's why these have to be memorized, like the back of your hand. Don't put them on the back of your hand. That's cheating. Some people, I think, would, if they could, would get a tattoo of the unit circle on their back of the hand, so they could do well on the net. I'll just shut up. All right, sine of x over 1. I should actually allow that. If you get a real tattoo that you're going to have the rest of your life of the unit circle on your hand, you can go ahead and do that. Would you do it? Oh, okay. All right. She gave me a look of horror and said, no. I have 3 daughters. I get that look 3 times every day. All right. I didn't want to tell you what the wife does. Poor Mr. Samuels. Oh, sorry. I just went somewhere for a second. All right. So secant is 1 over cosine. Did we get out at 52? An eternity. That's how it feels like every day in this class. All right, you guys, that's what you say. All right, so here, notice how I did this though, not to go too fast. This equals 1, and then I know I wanted to make this 1 over cosine, so I made the sine over 1. You know, I want to make sure I have my numerators and denominators separated. All right, and then I think I should really do this. I should really, yeah, sort of. Okay, this is 1 over sine. I'm writing on the screen. There we go. We're back. Okay, sine. Oh, what's it? Did I break something here? There we go. Sine over cosine. And then what is 1 over sine over cosine? What does that become? Cosine over sine. So these, it's not the trig identities, it's fractions. That's why I've been a fraction jerk all year long. I know when we get to like so many things deal with fraction rules, you wouldn't even know. And what's cosine over sine? Cotan. Kid, if you're not like doing any thinking and doing any like thought process about how I'm getting cotan out of that because of these pages here, you're at level 0. We got to move on. You got to memorize these. You got to have a feel for what is happening here. All kidding aside. Okay, now these are weird, but they're actually good in a way because if you look at these, and you haven't, I'm on my 3rd time, so but I'm in the notes and I want to make sure I get done. That they're actually telling you what the answer should look like. So f of x equals rewrite as an expression involving tangents and no other. So that better happen. Otherwise, they're really a jerk for those directions. We may be jerks, but we're not jerks with the direction. We're going to make this work. So you just got to do some math. It's really about your work to get there. So you better make sure you show that work. Now, you could say, there's, you know what you do on these? You do kind of want to think about them for a minute, maybe think a couple steps ahead. And if someone did make this 1 over cosecant, which is true, 1 over cosecant on the top is cosecant on the bottom, which makes that cosecant squared. And then you can do some flipping and so on and so forth. But you know what? Let's all keep ourselves on the same level right now and do the rule. The smart thing is to change this all in terms of sine and cosine and see what happens. And notice how very careful I am in the numerator. I'm writing a fractions. And then in the denominator, I'm writing fractions. And you want to keep these structures good. And I'm not asking anymore. If you don't know cosecant's 1 over sine, something's wrong. Really. All right, and then something's wrong if you don't know this, because I've been a jerk about this all year long. Dividing by 1 over sine is the same thing as what? Multiplying by sine. So the next step should be this. Okay, you know what? I'm going to put these together. This is sine of x over cosine squared. This is how I multiply fractions in grade school. All right. So I multiply the numerators, multiply the denominators. Nothing cross cancels. But then times, sine of x over 1. Someone might ask, where'd this go? Well, dividing by this is multiply flip. So that's what happens. By the way, what's sine times sine? So this is sine squared over cosine squared. What's sine over cosine? So it wasn't just tan as the answer. It was tan squared, right? So you don't have enough work here. I'm going to mark you wrong. If there's not enough structure to verify how you got to the end, then we're going to have problems. All right. So I got to see all that work building up to that. And it is dependent upon how fractionally challenged you are or not. If you are, and admit that you're fractionally challenged, write every single step and keep every structure good. All right. That really is a key there. Just look in the mirror. You know you. This is so easy, this one. And I'm not asking you anymore. I know it's the third time I've done this, but there really should be more than just note copying here. There really should be some thought processes here why we're doing what we're doing. Now this is across times, so can I cancel those signs? Yes or no? Yes, and then this is a basic mathematical structure. We did this in August and September, the prerequisite chapters, and then we did stuff like this when we had rational functions in the AP version of this. Now, what does it say? Oh, in terms of secant. Well, guess what? 1 over cosine is what, everybody? So they're kind of directing you. That's why I need to see this work. All right, you have this typed out in front of you so you can see this, and I don't have to. Now the next couple are a little bit more involved. I'm glad we do have a little bit more time, but we'll see how it works. You may not like this one because this does involve fractions, but again, this is fumble. What you have to do in order to do these, you have to have a little bit of vision. You have to have a little bit of future, like what am I trying to accomplish? And it says put it in terms of cosines, so somehow that's supposed to happen. Well, I'm just going to do my thing. Tangent is sine over cosine. I'm doing that because I don't see any cotans, so that doesn't help me to change it to 1 over cotan. Useless. And then I'm going to keep my structure. This is sine over 1, all right, just to know where sine belongs. And then cosine is just cosine. What? And it's plus. Here's number 1. Here's another reason you should be arrested. You should be arrested immediately if you cancel these cosines. Can you ever cross cancel across a plus sign? Yes or no? These are the people that will get no credit on these. That is not me. That is not blame nobody but yourself, not knowing your fraction rules from grade school. I'm sorry. I have to go that way every single year I teach pre-calc. It's not the pre-calc. It is never the pre-calc. It is the being, the work ethic, but also stuff that you came into which might involve work ethic from the previous 2 years. I'm just going to go ahead and do this. Why did I do this? Because I had a beautiful question before where I saw sine squared plus cosine squared. What was sine squared plus cosine squared? What did that become? I'm going to cry. What's sine squared plus cosine squared? 1. And I want that to happen. Here's another reason. Now I have a They said it. They said it. Common denominator. So it's just like this. I don't know why I keep doing this to myself. 2/9 plus 3/18. Why is he doing this one? Because it's the same concept. What's the common denominator between 9 and 18? 18. So what does that mean? I have to multiply this by 2. It's missing a 2. I'm going to keep going. 2 times 2 is 4. 4 plus 3 is 7. This is 7/18. Boy, you just keep reaching in that bag, don't you? All right, 7/18. All right, right? 18. The common denominator comes across. So this becomes, fine, I'll make this sine squared. I'll make this cosine squared. And then this is why we cannot blow a brain gasket on this. How did this become 1 cosine? That's like asking, how did this become 1/18? That's why I did this over here. It's all based off of grade school skills. It really, really, really is. And then what did I just say? Sine squared plus cosine squared is 1. And then what did it say? So leave it in terms of cosine. I got to leave this alone. But what is 1 over cosine? Secant. All right, the bell's going to ring on us. I'll continue on this last one as they walk out the door. Okay, so which one is not equivalent? Wait a minute. What is this? This is a Pythagorean identity. I'm going to do this a little bit different. What is that Pythagorean identity? X squared plus y squared equals r squared. What's cosecant? Cosecant is r over y. So I divide by y squared. What I got to find out is this actually equal to cotan? Which therefore then would knock this one out. Boy, I hope my sound is working. So this is, okay, cotan squared. Let's use that b. That's beta. Plus 1 equals cosecant squared. Oh, then if I subtract 1 and square root, darn tootin', that is equal to cotan. So that makes this not equivalent. Yikes. All right, don't tell me you're turning in your homework. All right, just had that happen. Are you turning in your homework? Oh, okay. Third in. You were doing it during the notes, were you? Like my bums from last hour. That is the definition of cotan. So that is not cotan. So I got to get rid of that. So the next one, secant, is 1 over cosine. Cosecant is 1 over sine. All right. Wait a minute. See ya. Bye. And then divide is multiply, flip. So just to save time on this, wait a minute. Sine over cosine, that's tangent, not cotan. So I know it's C. Let me check the last one. This one kind of stinks. This is 1 over sine. This is 1 over cosine. This is sine over cosine. You have something? Or are you just watching? And then guess what? I'm going to get a common denominator again. So I have to multiply by sines, but here's another reason. Sine is sine squared. 1 minus sine squared is cosine squared. And now that I have a common denominator, I can put them underneath 1. Now this is a highly complicated, but once these cancel, this is cotangents. And that's what I'm trying to not have happen. So that is why that one is out as well. So I knew C was the right answer. I just wanted to prove D was cotan as well. All right, movie over. Gosh, I hope the video works.